In lesson 86, we're going to learn about dividing polynomials, and let's just go ahead and learn this by doing some practice problems. Look at practice problem A. We want to divide by x, divide that polynomial in parentheses by x. So something we could think about here is if we thought about that as a fraction, instead of with the division symbol, we think of that as everything over x. And so we could say 3x cubed over x plus 2x squared over x minus 5x over x. We can think about it that way too, right? Or we could have it all over the same denominator of x. But it's just easier to think about for division purposes to break them up into individual fractions. And so now we can use our negative exponent rules that we know about. X cubed over x would just be x squared, and so we'd have 3x squared plus 2x minus 5. And so that's all we do there to divide a polynomial like that. So problems like A, practice problem A, those are pretty easy to do, the division of those. Where it gets complicated is if you have to divide by a binomial, like in practice problem B. And the best way to set this up is to change this to long division format. So when you have to divide by a binomial, change it to long division format and just put your x first. Say x minus 1, put your long division symbol down, and 3x cubed plus 2x squared minus 5x plus 7. And so that big polynomial, that's considered your divide or dividend, and the x minus 1 is your divisor. That's what you're dividing by. Now the process is similar to long division. Let's just do a long division problem real quick with numbers just to refresh your memory. For example, if we were doing that, 42 divided by 3, we would take that 3 and we would see how many times does 3 go into that 4. We're trying to get rid of or reduce that 4. So we say 3 goes into 4 one time. So we put a 3 down here because 3 times 1 is 3. We do that multiplication. 3 times 1 is 3. Subtract, and we have 4 minus 3 is 1. And then we bring down the 2. And we say, well, how many times does 3 go into 12? We're trying to get rid of that 12 as much as we can. It goes into that exactly 4 times. So we say 3 times 4 is 12. Do that subtraction. That equals 0. And so there's our answer, 14. And then remember, if you had a remainder on that, if you had not got 0 for a result on that at the end there, you could have figured out a decimal form or written the remainder as a fraction over 3. Now keep that process of long division in mind to divide this polynomial. So we have to get rid of that 3x cubed. Basically, that's what we're trying to think of, is to get rid of that 3x cubed. And one of the factors that we have is our divisor, x minus 1. So we just have to think about what could we multiply x minus 1 by to get rid of 3x cubed. Well, we could multiply it by 3x squared, right? Because 3x squared times x is equal to 3x cubed. And then we need to do the minus 3x squared. We need to expand the whole thing out. So if we do that, we can put 3x squared in our quotient. The quotient is up at the top. 3x squared, and then down here we'll do the product of 3x squared times x minus 1, which is 3x cubed minus 3x squared. Now remember, we're subtracting what we just wrote down. We're subtracting that out. So we've put a minus out front here. And so we're saying 3x cubed minus 3x cubed is 0. And then 2x squared minus a negative or plus 3x squared. So that would be a 5x squared. And then we bring down our negative 5x. Okay, now we want to get rid of the 5x squared. So we think, what can we multiply x minus 1 by to get 5x squared? Well, that would just be a 5x, right? So that would be 5x squared minus 5x. And so up here we'll put positive 5x, and down here we'll have 5x squared minus 5x. And so this is subtraction. Remember, it's subtraction. So if you want to, just put a minus around all of this and think of it as algebraic addition. So we'll have 5x squared minus 5x squared is 0. And then we'll have minus 5x minus a negative or plus 5x. So that's 0 as well. And then so what we have left is a 7. We bring that down. X minus 1 can't go into that any, so that's our remainder, 7 over x minus 1. So there's our answer right there that I'm putting the box around. 3x squared plus 5x plus 7 over x minus 1. So what that means is if you divide 3x cubed plus 2x squared minus 5x plus 7 by minus 1 plus x, or x minus 1, you get 3x squared plus 5x plus 7 over x minus 1 as a result. Now we can always check our work to make sure we did it right. Let's just go ahead and rewrite our quotient over here, 3x squared plus 5x plus 7 over x minus 1. Now the way we can check our work is to rewrite this everything over x minus 1, and that would get us back to our original division problem. So that means we need to multiply above and below by x minus 1 here with the 3x squared, and then the 5x also needs to be multiplied above and below by x minus 1. We don't do anything to the 7 because it already has a denominator of x minus 1. So if we do this, we'll end up with 3x squared times x is 3x cubed minus 3x squared, and then plus 5x squared minus 5x plus 7. That's our numerator. Simplify that and we get 3x cubed, and then minus 3 plus 5 would be a positive 2x squared minus 5x plus 7. All of that over x minus 1. See, that's our original polynomial, 3x cubed plus 2x squared minus 5x plus 7. So that tells us that we did the division correctly. Now those can be a little bit confusing, so just be patient. If you need to rewind the CD and go back over how we did that last one, then do that. Let's go ahead and do another practice problem though. This one we want to divide that polynomial by x minus 3. So we go ahead and write x minus 3 as our divisor. We use the long division format here. And so we'll have 4x cubed minus 2x squared plus 5. Okay, so let's go ahead and do our division. We need to figure out how to get rid of that 4x cubed. What could we multiply x minus 3 by to get rid of 4x cubed? And so just think about it. You can do this over to the right if you want to, or to one side or the other. Think about what to multiply that by. When you expand it out, it would get you 4x cubed, and that would be 4x squared, right? Because if you did 4x squared times x, that would be 4x cubed. And so let's put 4x squared up here in our quotient, and then we'll have 4x cubed, and then 4x squared times a negative 3, that's negative 12x squared. Now remember what we're doing here. This will all be subtracted from the dividend. So we put a negative out in front of it, and we can think of algebraic addition. 4x squared plus a negative, 4x cubed plus a negative 4x cubed, that would be 0. And then minus 2x squared plus a 12x squared, because we have minus times minus, that would give us 10x squared. Now, if we brought the next thing down, that would be a 5. But here's something else that you have to keep in mind on these polynomials. You have to go in descending order of the powers. just for purposes of keeping up with the pattern of division. So you have to have a 4x cubed, and then if you got an x squared next, or you would have an x squared next, you need an x term after that, x to the 1. So in the dividend, just put a 0x in there. I mean, it's equal to 0, but it just helps you keep up with your pattern. And really that 5 on the end is 5 times x to the 0, but we don't worry about the x to the 0. So now we have x to the third, x to the second power, x to the first power, x to the 0 in our constant term. So bring down the 0x, because you're going to have something to subtract from in a minute, and you'll see what I mean. Right now, though, let's concentrate on getting rid of the 10x squared. So we have x minus 3 as a factor. What would we multiply that by to get 10x squared? Well, that would just be a 10x. So we put 10x in our quotient, and so we do 10x times x is 10x squared, and then 10x times a negative 3 is negative 30x. Do the subtraction. Remember, all of this is subtracted. So we say 10x squared and a negative 10x squared is 0. 0x minus a negative, so that would be plus 30x. So this is going to be a positive 30x. So do you see why we needed that 0x in there? Otherwise, we would have brought the 5 down, and we wouldn't have had a like term to subtract that 30x from. Now we can bring down the 5. And now we think about what we need to do to that 30x to get rid of it. And so we have x minus 3. What could we do to that to get rid of the 30x? We can multiply it by 30, right? So we'll have up here a plus 30. And so 30 times x is 30x. And then 30 times a negative 3 is a negative 90. We're subtracting all of that from the previous part, so this will be 0, and then we'll have 5 minus a negative, or 5 plus 90, so this will be plus a 95. And so that's our remainder is 95, and so we write that 95 over x minus 3. And so that's our quotient for that result. So one of the important things on this problem to remember is to keep the division pattern going, we had to add a 0x in there. I mean, that just equals 0. We know it does, but it just helps us keep our descending order of the x variables in the appropriate pattern there. And that helps us do, when we need to eliminate and do subtraction, we eliminate and subtract the right parts, and we have like terms to subtract. Let's do one more. Let's divide x cubed plus 4 by x minus 4. Now, there's nothing you can factor out in this problem. You'd have to have a common factor in the numerator and the denominator to simplify that. So that's not what they mean here. They want you to use the long division format. And so let's put x minus 4 as our divisor, our division symbol, and then x cubed is first. Now remember what we learned in practice problem C. We need to have descending order of the variables in order to get our division pattern to line up correctly. So we'll have x cubed, then we need to put a 0x squared and a 0x, and then 4x to the 0, or we can just leave that as a 4 there. Now when we do our division, we'll have an appropriate pattern. We'll have everything lined up the way it needs to be. So we have x minus 4 over to the left, and this time I'm not going to rewrite a pair of factors over to the side. Let's just do that in our head. Think of x minus 4. What could we multiply that by to get rid of the x cubed? And that would just be x squared, right? So we'll have x squared there, and multiply that by x would be x cubed. Multiply it by the negative 4, and that's negative 4x squared. This whole thing is being subtracted from the dividend above. And so we say x cubed and a negative x cubed is 0, and then 0x squared plus 4x squared, because it's minus a negative, so that would be a positive 4x squared. Bring down the 0x. Okay, so now we need to think about how to get rid of the 4x squared. And so we see we have x minus 4. If we multiplied by 4x, we could get rid of it. So we say in our quotient plus 4x. 4x times x is 4x squared. 4x times a negative 4 is minus 16x. We think of all of that in parentheses, and we're going to subtract all of that from the part above it. And so we say 0, we got rid of that, and then 0x plus 16x would give us a positive 16x. Bring down the last term, 4, and now we need to get rid of 16x. So we could multiply x minus 4 by a positive 16. And so we'll put plus 16 in our quotient. 16 times x is 16x. 16 times 4 is a negative, 16 times negative 4 is a negative 64. We're doing subtraction here, so we put a subtraction out there, and we get rid of the 16 x's like we wanted to, and we'll have 4 plus 64, which will be a positive 68. And so that's our remainder. We always write a remainder over the divisor, so that'll be plus 64 over x minus 4. We can put that in parentheses if we want to. So there's our quotient. X squared plus 4x plus 16 plus 64 over x minus 4. Make sure you put a box around that quotient so it's easy to find your answer. In a problem like this, it takes up a lot of space, and it's hard to tell what's going on sometimes, so it's a really good idea to put a box around that answer so you can refer back to where the answer is. Give yourself some time to get used to doing these division of polynomial problems. Just be patient. You may need to watch this lesson again in order to figure them out and be more confident in doing them. Okay, well that's all for lesson 86.